Hey, and welcome everybody to Advent of Code 2022 Day 8. Quick thing at the top of this, I am on the road today, not my usual setup, so this is going to be really quick, and also I apologize in advance for video audio qualities. Let's jump straight in. So, Day 8, Treetop House. Basically, we're given our input, it's sort of like a grid. The grid represents, here it is, it represents the height of trees in a forest, and our elves have launched a quadcopter up to generate this map, and now what they're trying to do is they're trying to figure out a couple of different things. So one thing they're trying to figure out is how many trees are visible based on their height from the outside of the grid. So we're told that all of the outside trees here are all visible, but for the internal ones you can determine that a tree is visible if from any direction that you were to look in at it from, you can see it from the outside. So here the height of that tree is 9, so behind was 4, behind this 9 and behind that 9 you can't see it. From this direction behind this 5 you also can't see it, so it's not visible that way, and from this direction behind that 7 it's not visible, so you're only looking at it from the 4 sides. So the first thing we're asked to do is to figure out how many trees are visible in our grid, and yeah, that's about it. So let's look at my code for this. So my code for this, first thing I've decided to do is to make a 2-dimensional grid that I'll be able to use then just as my main input to recurse over. So I read in the file line by line and I start assembling this 2D array with all of the heights of the trees. Other grid here, this will become apparent why I've done this in a second, but essentially I have 2 grids. One has all the X is in one line, and then the other one I flip it around so that it has all the Y's also in a line. Just makes it easier for the indexing to solve the problem. So what you have to do then is you're basically going to be looping through every single cell in this 2-dimensional array, and you'll be trying to figure out if it can be seen from the outsides. So you've got 4 directions you need to look in. So what I've done here is, so this is my 2-dimensional loop, which you're told that the outsides you don't need to worry about, so you can start from the indexed in 1 in each of them, which I've done here, and you only need to go to the width or the height minus 1 on each side. So we have, basically what I decided was the easiest way to do this was to make 4 arrays that contain all of the trees in each direction outwardly in like a star pattern from the one that you're on. So I call them left, right, up, and down. So this is some array slicing operations that give you a sub-array of all those trees. And what I'm interested in is I'll know that the tree is visible where it is from any direction if the tallest trees in each of those directions are smaller than the height of the tree I'm on. And also, we don't care by what direction it's visible, we just want to know is it visible or not. So I take the max value of each tree in each of those subarrays, and then I can do this conditional check in here. Basically it'll just skip if any of these don't match, but if this tree at this cell is taller than any of the max height trees in the lines on it, I'll increment a counter. So then we loop through that for every single cell, and then at the end, the count, we add that to some static stuff. So these static and that maths here is just the top row and the 2 side rows with 1 taken off each end, and that'll give you the answer. And does it work? Yes, it does work. Okay, so part 2. So for part 2, they don't really change it up too much. It's pretty easy, but basically what you want to determine is what tree has the best kind of views over the entire forest, or has the best observability. So what you're trying to figure out is from which tree, when you're looking in all directions, can you see the furthest without being blocked by either a tree that's taller or a tree that's of at least the same height as the one that you're looking at. What you do then is you look in all those directions and you get a number, which is the amount of trees you can see outward, and then you multiply those numbers together, and that gives you what your answer is. So say here we've got, say, tree 5 here from this position. If we look down, we can see 1 in that direction. If we look to the right, we can see 2 in that direction. If we look to the left, we can see 2 in that direction. Look to the right, we can see 1 in that direction. And then if we look up, we can see 2 in that direction. So then we've got our outputs are 2 times 2 times 1 times 2, which is 8, which is the answer to the puzzle. So to do that, it's relatively simple. We build our exact same grid that we did, and our loop is more or less the same. We have a 2-dimensional loop that goes through it. I figure out my arrays here, except instead of getting the maxes of each one, I actually want the arrays themselves to do some operations on them. I reversed 2 of them, and that's just because I wanted them all to start with the first index as if I'm starting at the base of the tree and walking away from it. So I had to flip 2 of them around to get that. And then from there, I do this other nested loop. And basically what I do is, for each of these arrays, I go through each array, and for each of those, I go through each tree in the array, and I keep incrementing an index until I hit a tree that's the same height or greater than, and then I stop. And then at the end, I collect all those down, add them together, and then at the very end here, once I've done each direction, excuse me, I multiply them all together with this injective function, and then you're only told that you want the greatest number from that. So what I do here is I have a score initialized to 0. I reset the score if it's greater than it, and then output the score. And there we go. There's our answer. This is the first time where I've seen the approach that I use for both parts not to have very similar runtimes. So the first part of this runs very, very quickly, and the second part runs quickly, but not nearly as quickly. So there's a bit of a magnitude shift in the runtime. So that means that this isn't as optimal a solution for both parts, which means that this isn't the most optimal solution, really. There's probably a way cleverer way to do this, but I'm under a bit of time pressure today, so this is the best I can do, I'm afraid. Anyway, I hope you guys enjoyed that. Hope you're still having fun with this. In my opinion, this was a way easier problem to solve than yesterday's problem. And yeah, it was a bit of fun doing it. So yeah, hope you guys enjoy, and I will see you all tomorrow.